Okay, so this is part 2 of curve fitting with linear models, and we are today going to use our graphing calculator to create a linear model and then use it to make predictions. So last time we talked about what a correlation coefficient is, and this is a number that gives us the strength of the relationship between the two variables. And we want that to be really close to 1 or -1. And we started talking about what that means. And we use these two couples to represent that. Now visually, when we have graphs, we really want data that is, like I said, correlation coefficient strong, so closer to 1 or -1. And you can see that first picture here. This is a pretty strong negative correlation. This is a really strong positive correlation. Notice both those, the R values close to 1. Okay, so what makes up a strong correlation coefficient? We talked about this a little bit last time, but really we want our correlation coefficient R to be greater than 0.75 or less than or equal to -0.75. So one of those two, all right? Otherwise, the data is not as strong and it's not as reliable to make a model with. Okay, before we start, you're going to need to use your MCA calculator for this assignment and lesson. So make sure there's a couple things that we have to do. We have to be able to find the correlation coefficient and line of best fit. Your calculator won't be able to do that unless you turn the diagnostic on. So to do that, I'm going to pull up my graphing calculator and try to do a split screen. Sometimes this has a hard time. Okay, so you want your grades 8 and 11 graphing calculator. I'm going to pull it up. Okay, I'm going to make this a little bit bigger. Okay, so to do this, we need to press second and then 0. So second, 0 for catalog. And now I'm going to scroll down to where it says diagnostic on. These are alphabetical. So it's a little ways down. There we go. Diagnostic on. I'm going to press enter and then one more time until it says done. Okay, that's step 1. So now step 2, you can kind of see here, it says we also need to turn our scatter plots on. So there's the steps, but I'll just show you here on the graphing calculator right now so you can see how this works. So what we have to do to turn our scatter plot on is right above the y equals, it says stat plot. So that's in blue. So we're going to press second y equals. Now your first one, notice plot 1 is off. So you're just going to press enter. And now it's blinking, the cursor is blinking on. Press enter again. So it stays there. And then we want our first type to be a scatter plot. Make sure this says L1 and L2. It should already. You can choose which mark you want. I like that first one, and then you can also pick the color that you'd like your dots to be. Now you're going to get out of here. So in order to quit anytime, you just want to go to second mode. So second mode to quit and go to the home screen. Okay, so now we're good so far. Okay, so now I'm going to make this a little bit smaller. All right. So we are going to make a scatter plot. Here it says anthropologists can use the femur or the thigh bone to estimate the height of a human being. And so then they give us some data here, and they have the femur length and the person's height in centimeters. Okay, so now it says step 1 to make a scatter plot of this data. So I'm actually going to need this data here, and we're going to type that in. So how do we do that? I'll make this a little bigger so you can see that. How do we do that? You're going to press stat for statistics again, and we are going to enter in some data. So we're going to edit. So press enter. And now under L1, you're going to put the length, all the X values. So I'm going to take a moment here to do that. 36. You can do this with me here. Okay, and then you're just gonna hit the right arrow key and go over to the second list and type in those values. Those are our Y values. Okay, so now our data is entered. Okay, so now to make a scatter plot, you're going to press stat again. Okay, so this time we actually, oh, just kidding. We want to make a scatter plot. You just need to press graph. Sorry about that. So we're going to press graph. And then now notice those points don't show up. So all we really have to do now is just press zoom. And we're going to change the window. So for scatter plots, they already have a window set up preset. So it's zoom stat number 9 down there. So you're just going to press 9. And then this should come up. This is my scatter plot. You'll notice it's a positive correlation and those dots are pretty close together. So you can draw this here on your graph, or you can also take a screenshot of this, crop it until you have that, and then paste it in there for your assignment. I like to do that because it's kind of neat. But you can draw it too. Just make sure it doesn't have to be perfect. You don't have to label any of the things just so it looks like that. Make sure it looks just like that. So I did that. I just took a screenshot and pasted it in there. You can do that. You can see there on my screen. Okay, so now that you have your scatter plot, you can see that's a pretty strong correlation. We want to find out how strong. So the second thing they ask us to do is to find the correlation coefficient R. Okay, and I was kind of getting ahead of myself and starting that already. So we're going to do that right now. So here's how we do that. You're going to press stat, okay, and now go over to calculate. And we want, this is linear regression. Remember, regression is the statistical study of relationships between variables. So we want to go down to 4. Actually, you can just press 4 or scroll and press enter here. I'm just going to press 4. Now, you want it to calculate this. So you're going to scroll down to where it says calculate and just press enter. Okay, so now you should get this information here. I'm going to make this a little bit smaller. All right, correlation coefficient. So now in here, we are going to write this. Now you're going to round this to 2 decimal places. So I want my correlation coefficient is that last one, R equals 0.9859. I'm going to round that to 2 decimal places. So R equals 0.99. So I want to round to this decimal place. So that next number was a 5, so I round up. So 0.99. That's very, very, very strong data. Okay. Now, the next thing I want to do is I want to find the equation of the line of best fit. So this is kind of tells you here. It says y equals ax plus b. That's the same as mx plus b, but instead of m, they use a for some reason. We are going to take, notice the a is 2.91453, etc. We're going to round that to the nearest hundredth as well. So we're going to put that in for our m. So it's 2.91x, and then plus b, and they tell us that our b is 54.0415, etc. We're going to round that to 2 decimal places as well. Okay, so now I have y equals 2.91x plus 54.04. This is my linear model, okay? It's my line of best fit. You could type it into the y equals screen and draw it in there if you want, but this is the model that I want to use to predict, okay? So the second thing here, or the next thing is, it says a man's femur is 41 centimeters. Predict the man's height. Okay, well, oops. Up here, femur length is x, height is y. Okay, so if I look at that table, right, x, y. So what did they just tell me? They told me the femur length is 41. So that means I'm going to take this value right here, and I'm just going to put it in for x. So if y equals 2.91 times 41 plus 54.04. So, okay, I'm actually going to do that right here. Okay. 2.91 times 41 plus 54.04. That gives me 173.35. Okay, so that means the man's height was 173. I'm going to close out the calculator now so we have this full screen. So the man's height is 173.35 centimeters. Okay. All right. And then lastly, so this is my answer for that part. And then lastly, is this an accurate prediction? So first of all, your data is accurate if your correlation coefficient is above 0.75 or below negative 0.75. So is this accurate? Yes, because of my correlation coefficient is very, very strong. And also, does this answer make sense? Make sure you look to see if it makes sense. Sometimes linear models only work for certain segments. So yes, this makes sense, but this answer 173.35 does make sense in the context of here. If I look at 40 and 41, it looks like it fits in that table fairly well. So I want to look at those two things to see if it's an accurate prediction. Otherwise, it's not good data to use. Okay. All right. So then here I just did put all the answers in there in a little bit nicer way. However you want to go about that. But again, I like to crop and paste that. You can also draw the scatter plot. And then notice again, part E, I said yes, R is very strong and the answer is reasonable. Okay. All right. So this is what you have to do when you do your assignment. Now, once again, I'm also going to post a script for this, and it looks like this. Don't forget to turn your diagnostic on and turn your scatter plots on before you start your assignment. And then I have here's the script for scatter plots. Okay, follow that, and then this is how you find your R and your equation for your line of best fit. Okay, so if you get confused, you can have that as a reference. All right. And you can go ahead and get started on and do your assignment on these kinds of problems. The practice is going to be helpful for you, okay? Have a good one. Come in to Ask the Teacher.